This video will continue the lecture about piecewise functions. For example number 2, our job is to find the equation for the given graph. What we do notice is that we have a function g of x that has two parts to it. One part we can see right here, and the other part we can see over here. So we're going to start with the one with the domain that starts with the negative infinity for the x values. So we're going to find this one right here. If we take a look at this function, it should remind us of one of our parent functions. And I'll just kind of continue graphing it so we can see the picture there. That we can now see that this is the same thing as the cube root function. So the next question is that we have a cube root function. We can see that here's our 0, 0 point. It was not moved to the left nor to the right. It was not moved up nor down. And we can see from our direction point from over 1 up 1 that there is no multiplier as well. So this is going to be our equation, and it's going to be for all those values in which x is less than 1. So I'm going to write that down where x is less than 1. The reason why it's not equal to, we can see this open circle here, which means it's not equal to. So let's go see our second half. Our second half, we're going to highlight it here. We can see the parent function for that is linear. So now the question is, so we know then that this is going to have an x. The question is it been moved left or right, or up and down, and more importantly, if it has a multiplier. Well, we can see if we have these 2 points here that we can find our slope by going up 1 over 1. So we know our slope is going to be equal to 1. That's our multiplier kind of guy. Then the next question is, where is my y-intercept? Well, if I keep doing the slope of going down 1 over 1, down 1 over 1, here's my y-intercept at y is equal to 1. So I need a plus 1 for that. An alternative is by using what we know from the previous unit, that we can find the equation of a line if I'm given 2 points. So with 2 points, the first thing I would have to do is go find the slope, which we already found that to be 1. And the next one is to use y minus y1 is equal to mx minus x1, so that we can find the equation of this line that we're talking about. The next thing we need to do is to see what domain that exists. So we can see that it's everything to the right of when x is equal to 1. So we know it's going to be to the right of 1. But notice that we also have a closed circle here, so it can be also equal to that. Let's move on to example number 3. Here, for example number 3, our job is to graph our function and then to determine the domain, range, as well as the increasing, decreasing, or constant intervals. We can determine the domain and range and the intervals after we graph. So the first thing we need to do is graph. One of the first things I'm going to do is I'm going to look at just the first function up here. Notice that that one, we'll call it y1, is equal to x plus 2. We can see that this is a linear, so we would start off with our y-intercept of 2, and then our slope is 1, so it would be up 1 over 1, up 1 over 1. And we can see that this is going to be our line, and we can connect the dots to create our graph. So I will do that. But now notice that we see that it's only good for those values in which x is less than or equal to 0. That would be all of these values on this side. So we need to get rid of all those values in which x is greater than 0. So all of these right here need to go away. Let's go on ahead and graph our second function. Our y2 is equal to 1/2 x squared. So we know our parent function is x squared. and we know we have a multiplier of 1/2. Notice we do not have a translation left or right, nor a translation up and down. So we're going to start at 0, 0. And then we're going to use our tables for our parent function, which is 0, 0, 1, 1, 2, 4, 3, 9. But remember, we have our multiplier, which says we need to get half of those values. So half of 0 is 0, half of 1 is 1/2, half of 4 is 2, and half of 9 is 4.5. So let's graph those. So starting here at 0, 0, I'm going to go over 1 and up 1/2. I'm going to go over 2 and up 2. I'm going to go over 3 and up 4.5. 1, 2, 3, 4.5. And then we're also going to see what happens at 4. 4 squared is 16. Half of 16 is 8. So I'm going to go to 4 and 8. So we can see our parabola doing this number. And then we need to plug in what happens when we plug in -1, -2, -3, and -4. But we know that from our symmetry of quadratic equation that we know we get these points as well. So I'm going to do 2, 2, 3, 4.5, and -4, +8. Then we need to take a look at our domain restriction. It says it's only good for those values of x greater than 0. So we want to keep these, but we need to erase these that are on this side. Notice also that we have an open circle at our origin. So I'm going to make sure I write that here because it's not equal to 0. And that should be our graph. So now let's go find all the information we wanted to find about it. So our job is to go find our domain, our range, and any intervals that may be increasing, decreasing, or constant. Let's start with the domain. We notice, so one thing that we might want to remind ourselves about how we can find our domain is to take a look at the shadow that our graph would make on our x-axis. So all of these values would be squished onto my x-axis. These values would come down here, including that closed circle would be there. Then all of these would have a shadow going this way with our arrows at the end. So we can see that our domain is going to be from -infinity to +infinity. Let's see about our range. For our range, we're going to look at our points and we're going to push them up against our y-axis. So I'm going to start from the bottom. We can see that this will come down here with an arrow. All of these would be included. This one is solid, so it would include this point here. And we come on, all of these are solid, and we would sit there and have that. We can see then that our range would also be from -infinity to +infinity. Now let's go and decide about our intervals. So one of the things I'm going to do is see if I can find the little band baton, I guess. We'll do it in a highlighting. So we're going to start from the far left. We're going to see what's happening to our y values. We can see our y values are constantly increasing, then they kind of stop there. So we can say that it has an increasing interval from -infinity, that's the x value, all the way till we get to 0. But we can also see that it's going jumps to here, and it's going to be constantly increasing here as well. So we would say that it has an increasing interval again from 0 to infinity. That's our x values. So what I do want to point out is that these parts right here are describing our x values, while this part is describing our y values, what the y values are doing while the x values are marching from left to right. Notice I have my increasing intervals separated because our graph is also separated into two parts. Let's continue on to the next page with example number 4. Our job is to graph g of x, and notice we have 3 parts. After we're done graphing, our job will be to find the domain, the range, increasing, decreasing, and constant intervals if they exist. Let's start off with graphing our first function up here. If we call that y1, we can see that we need to graph x plus 1, which is a line. So we're going to come to our graph. We're going to go to 1, and that's our y-intercept. We're going to use our slope, which is up 1 over 1. We can see all these points here. And then we can attach a line to them. But we also need to notice that we have our domain is only good for those values where x is less than or equal to 2. So I'm going to come to my graph. I'm going to go to where x is equal to 2. And it says you can keep all the ones that are to the left of 2. That means everything to the right of 2 needs to be erased. The next question is, should this endpoint be an open or a closed circle? Notice that it says that x can equal to 2, so that's going to be a closed circle. Let's now graph our second equation. Our second equation is right here. It says y2 is equal to 3. This is a constant function. So in other words, it would be right here going all the way across at y is equal to 3. So we look at our interval. It says it's good between 2 and 4. It can equal to the 4, but it cannot equal to the 2. So that means I need to do some erasing. So let's take a look at these intervals, and we're going to see that x can equal to 2. That's this part right here. And that x can equal to 4, that's this part right here. So it says that as long as x is in between, we get to keep it. What that means to us is that we need to erase all of these guys right here up until we get to x is equal to 2, and we need to erase all of these that are over here that are greater than 4. The next question is going to be, do we have open circles or closed circles? At x is equal to 2, we have an open circle. So notice I'm going to put this green open circle around the closed-in blue one. And then x can equal to 4, so that's going to be a closed circle as well. Now we're ready to graph the third line. That's this one right here. So it's y3 is equal to negative 2x plus 7. So we know that's going to be our line. We're going to go to positive 7. And then we're going to use our slope of down 2 over 1. Down 2 over 1. And we're going to create our line here. The next thing we're going to realize is going to be our domain. It says this is good for anything greater than 4. So again, I'm going to come around and go to x is equal to 4. And we're going to keep everything that is greater than 4, which means I need to erase everything that's to the left because we're going to keep everything that's to the right. Now let's take a look if we need to have open circle or closed circle. Since we do not have an equal to, this is going to be an open circle. And we still have our line continuing all the way down. So that ends up our graph. We are done with our graph. We have graphed all 3 equations with all 3 domains set forth. The next thing we need to do is to determine the domain and range of our graph. Let's start with the domain, and we're going to start on the far left. We can see for x values going to negative infinity, if we were to do a shadow along the x-axis, we can see this will come around to here. All of this would be shaded. All of these would come down and include the 2. All of these would come down and include the 4 because this one's solid. And then all of these would have a shadow going all the way across. So we can see our domain is going to be from negative infinity to positive infinity. Let's see about the range. For the range, let's take a look at the y values, And what we're going to do is we're going to squish them into our y-axis. So that means if we look over here starting at negative infinity, we can see this will squish over here. And all of these will squish onto here. Even these would squish onto here. Notice right here at -1, even though it's an open circle here, it's closed over here. So it's included. That's included. All of these are included. And we kind of stop right here. Notice there's no y values up here to be squished up to here. So that's going to be our range. We're going to see that it's going to go from negative infinity until we get to +3. So there's our domain and range. The next thing we need to do is find our increasing, decreasing, and constant intervals. So we're going to start marching from the far left, and we're going to see when x starts at negative infinity, this is what's happening to my graph. We can see that the y values are constantly increasing. So we have an increasing interval from negative infinity, that's the x value, and then it stops right here at 2, but not including the 2. So now let's continue and see what we have going from the left to right. From here to here, we see that our y values are constant. So we have a constant interval, and it happens from our 2 until we get to 4. So we will say that our interval is from 2 to 4. The next thing we need to do is to take a look at what happens after the 4. We jump down here and we go down, 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 down. So that means it is decreasing. So we will write that we have a decreasing interval. And we're going to see from where. Well, it starts decreasing right here at x is equal to 4, and it goes all the way to infinity. So from 4 to infinity, we have a decreasing interval. And that concludes this video.